Hello guys, so welcome back to our course. This is lecture 12, and we're gonna now, go further in our discussion about, arithmetic, circuit design. So I mean, circuits that do arithmetic for you. So we explored last lecture in the adders, okay, the half adder, the full adder. Then we use this, basis, this full adder or half adder into a bigger designs, like for example, the binary adder and its extension, the carry look ahead binary adder, which is faster than the binary adder. Okay. And we're gonna, explore a little bit further on that discussion in that lecture for two other designs that are really important. At the same time, they are just based on the binary adder. Okay. So again, once you make a design, you can use it in the future. Just think about what you have all the time. Okay. And one usage for this binary adder that can add two binary numbers together is that you can use it to add three numbers together. Remember, the addition operation is associative. I mean, if you are adding three numbers like a plus b plus c, you can add a and b first, then add the result to c. And you can do, for example, a, then b plus c together, then add the result to a. Okay, good. So the problem is saying that add or design a circuit that add two or three numbers, binary numbers together. And we're gonna use this, idea here, this property we can say. So to add a and b, we're gonna need a binary adder. Then the result will need another binary adder. So we need two, basically. Okay. Also, it's not that simple. I mean, you must take care of some, special cases that can happen for you while adding numbers. So let's explore these cases. Okay. So let's have a very nice example, like adding 3 to 7 to 15. And we can, make a combination, adding 3 to 7 first, then add the result to m. I'm sorry, the 15. Then add, for example, the 7 and 15, then add the result to 3. We can do these two combinations, and we're gonna discover something really important to design this circuit. Okay, so let's add 3 and 7 first. So both are 4 bits because the others that we have is 4 bits. Okay, and 7, we're gonna express it again in 4 bits. So we must put zeros at the fourth location. Let's add these together. This is 3 plus 7. So 0 and we carry a 1, then 1 we carry a 1, then 0 we carry a 1. So this is basically the sum of 3 plus 7, which is 10, of course. And the carry is 0. So let's write it. The carry is 0. Okay. Then we add this to 15. So 15 is 1, 1, 1, 1. This is 15. And 15 is 4 bits. Then we add these. So 0 and 1 is 1. 1 and 1 is 0, and we have a 1. 0 and we have a 1. Then 3 ones. This will give us, a carry here. Okay. And if you see the result here is 16 plus 8 plus 1, which is 25. And of course, 3 plus 7 is 10, 10 plus 15 is 25. So the result is correct. But look at this. Where do you get the carry? You get the carry at the second operation. So this operation results in a carry. And the carry of the first operation was just 0. And remember, there is an output, okay, either from the first, from this adder or this adder, there is an output called the carry. So which one we should use? Based on that example, we should use the second one, okay? But let's do another, combination. Let's add 7 to 15, then add the result to 3. So here is 15, and here is a 7. And let's add the result. Then we add the result to 3. Let's add those first. So 1 and 1, 0 and 1, then 3, 3 again, then 2, and whoop, we have now the carry from the first binary adder. Then we add this to 3. 3 is just 1, 1, and 2 zeros. So this is 7 plus 15. So this will be 1, 0, and we have a 1, 0, and we have a 1, then 1, and look, the second carry is 0 now. So if we do 3 plus 7 plus 15, this will give us the carry from the second adder. And if we do 7 plus 15, then the result was 3. This will give us the carry from the second adder, from the first adder. I'm sorry. So which one to take? Looks like you should make a choice here. I mean, for example, if you want to take the carry from the second adder, you must put the 2, or the maximum number between the 3 numbers to the second adder. So, for example, if C is the maximum, then put C to the second adder, and put A and B for the first one. Okay. If you want to consider the carry of the first adder as your primary carry of the operation, then add the maximum to the first adder, binary adder, either for A or B, whatever. Or you can do something very smart. If you wanna, avoid all such complications and choose, because if you wanna do the first choice, you must find first where is the maximum, and this is another circuit. So you must have a circuit that we will explore this circuit, by the way, that determines the maximum number between some numbers or some inputs. Okay, which is really complex. But there is another, very interesting, modifications that you can do. You can do something like this. So here you are saying, if I put the maximum to the second one, okay, then the carry will be from the second adder here, if there is a carry. And, we're gonna OR it with the first one. And, you know that one of them will be 1. One of the carries will be 1, either the first one or the second one. Okay. So based on that, you can make an OR. So, for example, if we put the 7 here and the 3 here, and the 15 is here, which is going to the second one, okay, then the first operation will result in a 0, and the second operation will result in a 1. So the final out will be or 1 or 0 will be 1. Let's do that with another color. Now, if you put the 15 here and the 3 here, I mean, you put the maximum to the first one, then you're gonna get a 1 from that carry and 0 from that carry, and again you have a carry of 1. Okay, so that's basically, how you're gonna think. But basically, we didn't do something from scratch. We did something, I mean, based on a design that we already have. We just add a little tiny modification here for such tiny difference. Okay, to take into account this property that you might have the carry from the first one or the second one. Okay. Another we can say a problem, okay, in that circuit, that the output, you must use this circuit if you're sure that the output number, I mean the result, the sum, the overall sum, I mean this sum here, the overall is 5 less than or equal to 5 bits. So this circuit must be used only if the output or the final sum is less than or equal to 5 bits. For example, you cannot do 15 plus 15 plus 15. because the output here will be 6 bits, which is 45. Okay, so that's another limitation for that, although it has a still solution. Okay, if you want to do this 6 bits, there is a still solution that you can do something very similar to that solution here. Okay, so that's basically the overall circuit. So we have here two adders, 1 and 2. Then you put the 3 numbers in that way. The first number and the first and second number to the first 4-bit adder. Then the third number together with the sum of the first adder to the second adder. Okay. Then the sum will be the overall sum will be the output, of course, of the second adder, and the overall carry will be the OR between the carry of the first adder and the carry of the second adder. Okay, guys, that was basically how to modify this circuit, or how to use it again in order to achieve more complex circuits without doing from scratch design. Okay, thank you very much for watching this video, and see you in the next video. Bye bye.